I'm Nova.
I'm Alloy, and this is AgentStack Daily.
OpenClaw 6.8 added GLM-5.2 and Claude 4.5 roots, tightened provider IDs, introduced managed secret ref auth, bounded model browsing, and safer tool schema recovery for OpenAI and Anthropic calls. The terminal-based coding agent OpenAI Codex 0.141 landed as the current stable release, and the terminal-based AI coding agent Claude Code 2.1 is the current stable Claude Code line in the release readout.
Today, OpenClaw leads the agent harness update. Google's Nano Banana 2 and Nano Banana Pro image models arrive through OpenRouter. OpenAI ships LifeSciBench and deployment simulation. GPT 5.4 gets wired into a near-autonomous chemistry loop. GLM-5.2 goes open under MIT and leads open weights on the AA Intelligence Index. Radical AI argues the lab is the moat. Index share targets faster open model coding loops with a 20% acceptance length lift, and enterprise AI budgets hit the CFO wall. Plus the GitHub Project Radar, Model Discovery Check, Local LLM Spotlight, and 3 extras worth your time.
The through line is practical: more model choice, more routing pressure, and more scrutiny on whether an agent run is reliable, affordable, and actually grounded in the system around it.
OpenClaw 6.8 shipped on June 16 with changes across model routing, channel delivery, agent recovery, and local runtime behavior. The model catalog adds GLM 5.2 and Claude 4.5, and those entries use normalized provider IDs so the runtime resolves a route from a stable string instead of a brittle provider-specific alias. Credentials now flow through managed secret ref objects, which keeps secrets in the platform's secret store instead of inline runtime config. The model browser is also bounded, so an agent can choose from an approved catalog slice without enumerating every provider target it can reach.
The most important reliability change is tool schema recovery for OpenAI and Anthropic integrations. When a model returns a malformed tool call, the runtime validates it against the expected schema and falls back to a safer shape before dispatch. That is the kind of failure that used to look harmless until a bad argument hit a downstream API. Telegram also gets structured rendering for tables, lists, expandable block quotes, and intentional line breaks, with replies flowing through a CLI-backed path that preserves the final message shape. WhatsApp now honors configured ACP bindings instead of dropping them.
The recovery path got attention too. Account-scoped DM sends, generated media completions, final auto-reply messages, restart shutdown aborts, yielded subagent pauses, and session identity prompts now land on more predictable paths. Oversized OpenAI embedding batches split before they trigger request size failures. SQLite avoids write-ahead logging on NFS volumes. Stale iOS gateways reconnect when they fall out of foreground state.
Codex 0.141 and Claude Code 2.1 are the stable agent releases to pair with that stack readout. The practical implication is cleaner harness plumbing. OpenClaw gives builders more model routes, safer auth, stronger channel behavior, and fewer silent recovery failures. Codex and Claude Code remain the terminal-based agent surfaces many teams use to drive code changes against that kind of backend. The part to watch is policy. Once agents can see a wider model catalog, the approved bound matters as much as the model menu.
Google's Gemini 3.1 flash image, branded as Nano Banana 2, is now listed on OpenRouter under Google's provider route. It exposes image generation and editing through the same OpenAI-compatible interface many agent stacks already use for text models. The headline spec is a 131,072 token context window, which is unusually large for an image model and gives the system room for reference images, long edit instructions, and multi-turn visual iteration inside one conversation thread.
The builder value is the shape of the call. An app already using OpenRouter can switch to the Nano Banana 2 model identifier without maintaining a separate Google native client. Inputs arrive through the chat completion style request shape, image outputs return through the standard response payload. That makes it easier to wire image generation into an existing assistant, design tool, or agent loop that already handles multimodal messages.
Google is positioning this as pro-level visual quality at flash speed. That matters because image generation is often blocked less by capability than by interaction latency. If the model can return good edits fast enough, it becomes usable inside a live chat, a UI mockup generator, or a product customization flow where a user expects several quick revisions rather than one slow render. The large context also changes the session design. A visual agent can keep the prior prompt, the reference image, the critique, and the revised target in one turn.
The claims still need real-world confirmation. Key questions are pricing, rate limits, output handling, safety behavior, and whether the model follows complex multi-image prompts consistently. But the integration surface is real: one routed model string, one request pattern, a fast image model that can sit beside text reasoning in the same agent workflow.
Google also listed Nano Banana Pro, branded as Gemini 3 Pro Image, on OpenRouter. This is the higher-end image generation and editing model, built on the Gemini 3 Pro multimodal stack, with a 65,536 token context window and provider routing through Google's backend. The listing describes stronger multimodal reasoning and real-world grounding than the original Nano Banana line, positioning it for production work where instruction following and reference consistency matter more than raw speed.
Mechanically, Nano Banana Pro matters because text and image inputs share one context. An agent can send reference imagery, layout language, brand constraints, and edit intent together instead of splitting the job across a text planner and a separate image renderer. That is a cleaner architecture for workflows like branded asset generation, game concept iteration, product mockups, and UI design exploration.
The contrast with Nano Banana 2 is useful. Nano Banana 2 is the fast lane with the larger context window. Nano Banana Pro is the capability lane, with better grounding and reasoning over visual instructions. On OpenRouter, both use the same broad integration pattern, so teams can route between speed and quality without rebuilding the client layer.
The risk is the usual image model gap between demo prompts and production prompts. Complex edits, multiple references, text rendering inside images, and style preservation can all degrade under real workload pressure.
OpenAI introduced LifeSciBench on June 17 as an expert-authored benchmark for life science research tasks and decisions. The point is to measure scientific judgment rather than isolated factual recall. The tasks are built and reviewed by domain experts, so the benchmark targets the kind of planning, evidence weighing, and trade-off reasoning that shows up in real research work.
That is a meaningful shift for life science agents. A model can memorize pathway facts or answer textbook-style questions and still fail when asked to choose a next experiment, interpret conflicting evidence, or reason about constraints in a wet lab plan. LifeSciBench frames prompts as course of action problems, which makes the score more relevant for teams building literature review assistants, experimental planning copilots, or biomedical reasoning systems.
For builders, the practical value is a shared yardstick. Generic reasoning scores do not tell you much about whether a model can handle medicinal chemistry, assay design, or research prioritization. LifeSciBench gives teams a published reference point to cite when comparing models for life science adjacent work.
The caveat is that one benchmark is never the domain. Independent scorecards and competing benchmarks will matter. LifeSciBench pushes evaluation toward realistic scientific decision-making, which is the direction life science AI needs if agents are going to move from search helpers to research collaborators.
OpenAI published deployment simulation on June 16, a methodology for predicting how a candidate model will behave before it reaches production traffic. The core idea is to replay realistic conversation trajectories from prior deployments against a new model checkpoint, then measure how the new outputs diverge from expected behavior profiles.
The mechanism is closer to a behavioral load test than a static benchmark. A simulation runtime feeds the candidate model multi-turn interactions that reflect real user intent, real context length, and realistic conversation paths. The scoring layer then flags divergence in policy adherence, hallucination rate, refusal behavior, tone, and other safety or product dimensions. Instead of waiting for a post-launch metric to drift, a team gets a structured risk report before promotion.
This fills a gap between red teaming and monitoring. Red teams are good at adversarial creativity but cannot cover every normal prompt distribution. Monitoring catches failures after users see them. Deployment simulation uses production-shaped interactions to preview whether the new model changes behavior in the places users actually go. For any team with a logged conversation corpus and an eval harness, the pattern is adaptable.
The limitation is distribution quality. If the replay set reflects last quarter's users but the product has changed, the simulation can miss what is coming next. Privacy handling also matters because real conversations must be scrubbed before replay. Still, the method gives model teams a concrete gate: simulate, compare, inspect risk, then decide.
OpenAI and Molecule.1 published results showing a near-autonomous AI chemist built around GPT-5.4. The system improved a challenging medicinal chemistry reaction by pairing language model inference with Molecule.1's synthesis planning and reaction prediction stack. The point was not to have GPT-5.4 free associate chemistry. It was to make the model operate as a controller inside a constrained scientific loop.
Each iteration follows a practical agent pattern: propose candidate reaction conditions, score them through external chemistry tooling, feed the structured result back to the model, and let the model choose the next candidate. That turns GPT 5.4 into a policy layer over a simulator and planning system. The chemistry tools provide the evaluator. The model manages search, prioritization, and adaptation across rounds.
This is why the work matters beyond chemistry. Many domains already have deterministic simulators, scoring functions, optimizers, or trusted calculators. A language model becomes more useful when it can steer those tools instead of pretending to replace them. The architecture is the same shape as coding agents using test output, planning agents using pricing engines, or operations agents using deployment metrics. The value is a loop where each model proposal is judged by a domain system that knows more than the model does.
The open question is generalization. One improved reaction does not prove a universal AI chemist, and real wet lab deployment still needs human gates, safety constraints, and reproducibility checks. But GPT 5.4 class reasoning wired to domain-specific evaluators can search a technical space with less manual supervision. That is the practical route to autonomous science.
Z.AI released GLM-5.2 open weights on June 16 under an MIT license, with no field of use restrictions, no telemetry, and no output clause. The model is a 744 to 753 billion parameter mixture of experts with about 40 billion active parameters per token and a 1 million token context window, sitting on DeepSeek sparse attention.
The headline numbers come from the HF blog, Friendly AI, and Artificial Analysis. On AIME 2026, GLM-5.2 hits 99.2, ahead of Claude Opus 4.8's 98.2, GPT 5.5's 97, DeepSeek V4 Pro's 95.7, and Gemini 3.1 Pro's 94.6. On SWE Bench Pro, GLM 5.2 lands 62.1 versus Opus 4.8's 69.2 and GPT 5.5's 58.6. On Terminal Bench 2.1, 81.0 versus Opus 4.8's 85. The most concrete real-world signal is GDeepValley V2, an agentic knowledge work evil. GLM 5.2 scores 1524, beating GPT 5.5's 1514 and Minimax M3's 1418. Artificial Analysis puts the AA Intelligence Index version 4.1 at 51, leading all open weights.
It is also near the top of independent coding leaderboards. Frontier SWE has it at number 3 overall, behind Fable 5 and Opus 4.8 and ahead of GPT 5.5. Code Arena WebDev ranks at number 2 overall, behind only Fable 5 and ahead of Opus 4.7 Thinking. Simon Willison ran it on his Pelican SVG test and called it the best Pelican yet, fully animated, working wheels.
The trade-off is token efficiency. GLM 5.2 burns about 43,000 output tokens per intelligence index task, almost double Minimax M3's 24,000. Cost per task is roughly 46 cents, the lowest at this intelligence level. For builders, the practical answer is, run it where the workload justifies the compute, expect frontier-class coding and agent behavior. Day 0 serving is already live in VLLM, SGLang, Cloudflare Workers AI, OpenRouter, Olama Cloud, Base 10, Deep Infra, and Fireworks.
Joseph Krauss of Radical AI is arguing that in materials science, the moat is not the model. The defensible layer is the self-driving lab around it: robotic synthesis, characterization instruments, experiment orchestration, data normalization, and a closed loop that turns hypotheses into measured outcomes without a human manually operating every step.
The loop is straightforward and hard to build. A planner proposes a candidate material or synthesis condition. Robotic hardware runs the experiment. Instruments measure the result through techniques like diffraction, spectroscopy, or electrochemistry. The output is transformed into features, fed back into the planning layer, and used to choose the next experiment. The model is one component, but the bottleneck is physical throughput and measurement quality.
That reframes vertical AI. If the base model becomes interchangeable, defensibility comes from owning the operational loop that produces better data. In materials science, that means calibrated instruments, reliable robotics, clean measurement pipelines, safe unattended operation, enough experiment volume to create a flywheel. A lab that runs thousands of high-quality experiments is much harder to replicate than a better model.
The same lesson applies outside science. In logistics, healthcare, manufacturing, finance, and energy, the moat often sits in the workflow integration and the proprietary feedback signal, not the prompt wrapper. Radical's argument moves the roadmap away from model chasing and toward owning the system that generates truth.
The performance story for GLM-5.2 also rides on index share, a speculative decoding technique that Z.AI shipped alongside the model. In standard speculative decoding, a draft model proposes tokens and the target model verifies them. Index share lets the draft and the verifier share an index structure in the DeepSeek sparse attention path, so the target reuses draft-side routing hints instead of recomputing them.
The numbers from the Z.AI and Hugging Face blog ablation table are concrete. Baseline acceptance length on the GLM-5.1 backbone is 4.56 tokens. Adding index share plus KV share gets to 5.10. With rejection sampling and end-to-end TV loss, acceptance length lands at 5.47, a 20% lift. Z.AI also claims a 2.9x reduction in per token indexer flops at 1 million token context length.
For an interactive coding agent, that 20% acceptance length lift is the difference between the agent feeling responsive and the agent feeling slow while it streams a multi-file diff. The SGLang runtime recommendation for low-latency workloads is speculative algorithm Eagle, 5 steps, 6 draft tokens.
The catch: Z.AI did not publish official benchmark numbers at launch. The numbers above came out in the Hugging Face blog and the Friendly AI dashboard a day later. The early independent reaction from Latent Space, Simon Willison, and the Agent Arena maintainers is positive, but the model has been public for under 48 hours, so long-horizon agent reliability data is still thin. The real test is whether GLM-5.2 holds up inside a multi-file refactor session against a real repository.
NEA partner Tiffany Luck says enterprises are still working out AI return on investment after a year of aggressive adoption. The token maxing phase, where executives pushed employees to use as much AI as possible, is giving way to finance scrutiny. Reporting around the discussion included examples of companies burning through annual AI budgets quickly and trimming Claude licenses when the bill became too visible.
The mechanism is simple. Unmetered enthusiasm turns into uncontrolled inference spend. Every prompt burns input tokens, output tokens, seat costs, or both. Once usage scales across engineering, support, sales, operations, and internal productivity tools, AI spend starts looking like cloud compute. Finance teams then ask the same questions they ask about infrastructure: which team used it, which feature drove it, what output improved, why the expensive route was necessary.
The stack response is tiering. A flagship model handles high judgment work. Smaller models take routine summarization, classification, extraction, and drafting. Routing logic decides when to escalate. Usage telemetry maps cost to teams and product surfaces. Procurement reviews seats, caps, and rate limits. That is where enterprise AI is heading.
For builders, this changes the default assumption. A feature that works with a frontier model may still fail the budget review if a smaller model gets close enough. Open-weight systems like GLM-5.2 add more pressure by giving platform teams a self-hosted option for some text workloads. The winning architecture is not use the biggest model. It is root the smallest model that can safely do the job.
One quick beat on model discovery. Google's Nano Banana 2 and Nano Banana Pro both landed on OpenRouter this cycle. Both are covered in the slate above. Cohere's North Mini Code Free was also newly listed, but not selected for the broadcast because it is a smaller member of the North family mentioned on prior broadcasts, not a major standalone drop. Worth knowing it exists for builders who want to evaluate Cohere's first agentic coding model with a 256,000 token context at zero cost.
The local LLM spotlight is GLM-5.2. Worth knowing how to run it on your own hardware if you care about keeping prompts, tool traces, and source code off third-party servers. Z.AI released the weights under MIT with no field of use restrictions, no telemetry, and no output clause, and the headline reason to self-host is the 1 million token context window.
The practical self-host path is straightforward. Stand GLM-5.2 up behind an OpenAI-compatible endpoint with VLLM, point an OpenClaw-style harness at it, and run a multi-file refactor on a small local repo to see how the long context holds up across an extended agent loop. BF16 needs about 1.51 terabytes of VRAM, FP8 fits on 8H200S with headroom. For most teams, the realistic path is a cloud-hosted FP8 deployment through Cloudflare Workers AI, Base 10, Deep Infra, Fireworks, or Alma Cloud, with full self-host reserved for air-gapped or regulated environments.
3 repositories on the radar this cycle, each with a concrete integration angle.
Prefect HQ FastMCP is the Pythonic framework for building model context protocol servers and clients. It auto-generates schema, validation, and documentation from type hints, ships OAuth 2.0 with auth code flow, exposes an open API to MCP proxy, supports server composition, and runs on FastMCP cloud with a wildcard fast.app host. 25.7 thousand stars, 246 contributors, and the maintainers claim about 70% of MCP servers across all languages run some version of it. Latest tag is version 3.4.2 from June 6.
Wrap one internal function as a tool, mount it in a fast MCP server, and connect a Codex-style agent session to confirm the round-trip works end-to-end. Fast MCP replaces hand-rolled tool transports with a single MCP layer the LLM client already speaks.
Microsoft MCP for Beginners is a cross-language curriculum with 11 lessons aligned to the MCP spec dated November 25, 2025. Every lesson has working examples in C#, Java, TypeScript, JavaScript, Rust, and Python. The gems are not the intro chapters. Lesson 6 on secure, scalable, multimodal AI agents covers scaling patterns and security models an experienced builder will not already know, and Lesson 8 is early adopter case studies from teams that shipped MCP at scale.
Open the chapter that matches your stack's primary language, rebuild its sample server locally, then extend it with one custom tool tied to your own service. It is the shortest path to a shared MCP vocabulary across a mixed language team.
Unity MCP is a real Unity editor package plus a companion Python server that bridges Stio to Unity. Install through the package manager with the git URL plus the MCP for Unity path. Latest release is version 9.7.0 from May 22, supporting Unity 6, 2022.3 LTS, and 2023.x.
The agent capabilities are concrete: asset CRUD, scene editing, script editing with Roslyn-based compile validation before write, console log access, and multi-instance routing across several Unity editors. Attach the bridge to a Scratch scene and have the agent create a primitive, attach a material, and save in one go. That turns game loop iteration into a sequence of tool calls that is easy to difference and replay. 3 extras worth knowing about.
Odyssey raised $310 million at a $1.45 billion valuation in a Series B announced June 17. The lead investor is Natural Capital, with general partner Jay Javeri calling it the firm's largest investment to date. Amazon participated, AWS becomes Odyssey's preferred cloud provider, and Odyssey is collaborating with Amazon's Annapurna Labs to optimize world models on AWS Trainium chips.
The thesis is learned video world models trained to predict next frame pixel state, used as a planning substrate. Agents can roll out and search inside before committing to real actions. World models are positioned as the next layer beyond LLMs, and Odyssey is now the most capitalized startup betting on that direction.
Google shipped Android 17 and Wear OS 7 on June 16 with new multitasking features, parental controls, security tools, and a pixel drop that brings Google's latest AI models to its devices. The interesting integration detail is the refreshed split-stage activity embedding API, which lets Gemini share context and surface suggestions across the two apps currently pinned in split screen.
For builders, this matters because Android 17 opens the developer surface for cross-app Gemini assistance. Apps that participate in the split-screen embedding layer can be targeted by Gemini suggestions in real time, which is a new distribution channel for AI-aware workflows on Android.
Midjourney announced Midjourney Medical on June 18, a full-body, water-tank, ring-shaped ultrasonic CT scanner that uses sound waves instead of radiation or magnets. The user steps into a shallow pool and descends through thousands of ultrasonic transducers on rails. Claimed scan time is around 60 seconds, resolution down to a fraction of a millimeter. First deployment is a wellness spa in San Francisco, not a diagnostic device. Butterfly Network is partnered for transducer tech.
A real correction on the framing. Midjourney told Bloomberg they are not using AI yet, just hardware and reconstruction software. No diffusion prior as latent encoder. No clinical validation, no FDA clearance, and CEO David Holtz declined to specify cost. Roadmap is 10 scanners in San Francisco by 2027 and a target of 50,000 worldwide by 2031.
OpenClaw 6.8 widens model choice while tightening the paths that usually cause quiet incidents: auth, provider IDs, tool schemas, channel rendering, and gateway reconnection. Codex 0.141 and Claude Code 2.1 sit in the same builder reality, where terminal-based agent work depends on clean runtime surfaces behind it. Google's Nano Banana pair changes image integration more than image theory. Nano Banana 2 is the fast OpenRouter route with a huge context window. Nano Banana Pro is the higher capability Gemini 3 Pro image route.
OpenAI's science releases point in two directions. LifeSci Bench gives life science AI a more realistic evaluation surface, and deployment simulation gives model teams a way to forecast behavior before launch. GLM-5.2 is the open model pressure point. MIT licensing, sparse activation, and index share all push toward cheaper long text, coding, and agent workflows if independent results hold.
On tooling, FastMCP is the shortest path to wrapping internal functions as agent tools. The MCP for Beginners curriculum is the best shared vocabulary for mixed language teams, and Unity MCP makes game loop iteration diffable. The enterprise ROI story is the constraint around all of it. The stack that wins can build, configure, deploy, and measure model use without treating every request as a blank check.
For links and the release details behind these stories, look at the show notes at tobyonfitnesstech.com. Thanks for listening to AgentStack Daily. We'll be back soon.